Understand magnetic field strength. Since 1600 AD, when William Gilbert put his scientific genius into writing, creating one of the most admired books in history, the De Magnete, many scientists have embraced the field of magnetism as a field of great possibilities. Magnetic fields work around the principle of magnetic materials and electric currents and its effect on other materials with magnetic and electric characteristics. A magnetic field at any given point is specified by both a direction and a magnitude. As such, it is a vector field. Magnetic field strength is the measure of the magnetic field's intensity. There are a variety of physical phenomena and simple processes in physics that can show how a magnetic field works. One simple example is a compass. When a compass pole is placed near the north pole of a magnet, the needle points away from that direction and vice versa. This effect is commonly tagged in magnetic physics as opposites pole repel, similar poles attract. A typical physics experiment that you may have done in high school is when you place iron fillings in a magnetic field line. Since iron fillings have magnetic characteristics, just imagine how much it would be affected in a field line. This experiment visually reveals how the field lines are altered in the process due to the magnetization of the iron fillings. Polar auroras, which are streaks of light created in the Earth's magnetic field, also prove the same. When talking about magnetic field strength, you must understand how magnetic flux density works. Since magnetic fields can be visualized as magnetic lines, you can easily determine its strength by observing the density of the lines. This makes the magnetic field strength. The total number of lines emanating from the magnetic field that penetrates into a certain area is called magnetic flux, expressed in Tesla meters squared or the Weber, WB. This magnetic flux density is directly proportional to the electric current measured in amperes and is decreasing as it goes away from a current line. Magnetic field strength is a way to segregate the external magnetic influences of different magnetic materials. For example, when placed near magnetic fields, a magnetic material with its own internal magnetic field would interfere with the existing magnetic field lines. Since there will exist two sets of magnetic field lines, scientists must find a way to know which field lines come from which material. This is where magnetic field strength, represented by H in the equation B equals μ0, H plus M, has come up. Magnetic field has grown into a complex and wide-embracing science as it has been focal point in some of the most advanced sciences we have today. Among those fields using the theories of magnetism and magnetic fields are electric motors, dynamos, Helmholtz coil, magnetic field viewing film, Maxwell coil, Teltron tube, and stellar magnetic field. Also, it has been associated with different mathematical equations and laws such as Ampere's law, Biot-Savart law, magnetic helicity and Maxwell's equations.